Okay, good morning all.
Good morning, sir.
Morning, sir.
Morning, sir.
Good. Hope you all in a good and healthy condition. Uh, okay, today let's start our lecture. Today we will discuss the distributed and internet system design. So this is the design consideration. Okay. When you have uh, distributed geographical location, it means your application, your system will be used and accessed by users that are in different geographical location. As a user, I believe you already familiar with this kind of systems. All your application all application inside your mobile phone, your tablet is distributed and internet system. Okay. If you upload a picture to Instagram, your picture might be taken and stored in your mobile phone here in Indonesia. But then when you uploaded that picture to Instagram, it will be stored and managed somewhere in the US, perhaps, or even Singapore, or everywhere. You don't know. And that's the system that we will discuss today. Okay, let me share my screen. Okay, can you see this, the PowerPoint?
Yes, sir.
Okay, good. Now, distributed and internet system design. So we are on the last uh, subphases of design. Okay, then we will move to implementation and also maintenance on the next lectures, which is the last two lectures. Okay, so when you have a system that can be used or accessed beyond the boundary of your location, okay, there will be new problems, new considerations, and new issues to be considered. Okay, there's also security. For example, you have to make sure that the user accessing your system from maybe US or Australia or Singapore is the actual user, the legitimate users. Okay, you have to ensure reliability. I think you already have experience with reliability last semester when the time come for exam and the exam was hosted in kuliah site, and you when the time for the exam you find out that kuliah site was uh, having problems and you could not access it. That's a reliability issue. Availability, survivability if there is some kind of disaster struck, and also performance where the system should be able to cope with increase in workload. Okay. So, what's the design deliverables and outcome? Uh, this is a design to incorporate different side of the system, data usage. You might not notice, but for you, for examples, you pay if you have a internet connection package for your mobile phone, for example, you pay for quota. I don't know how much the quota. cost for you. I can't remember exactly because I'm using postpaid account rather than prepaid, but yes, you have to pay. The website that you access, Facebook, Instagram, even Atmajaya, also pay for that connection, and it's much more expensive than the quota that you have. Okay, and also how to provide infrastructure for that, but we will discuss this. Okay, so distributed system, there are two main architecture or design, if you like, which is the file server and client server. Okay, file server usually used in local area network, which is the network within single building or the same location, just like our campuses. Okay, in our campus, in our building, building 3, St. Bonaventura building, we use local area network. You probably I already shown you the cables that connecting computers in the classroom through the other services. Okay. So file server. Servers is a servers that store your files. Okay. The modern version of file servers is all the online or cloud storage that we have right now. You probably have access to iCloud, you probably have access to Google Drive, you probably have access to Dropbox or OneDrive in Microsoft. Okay, so what happened was you store the file here, and whenever you need it, you just take the file and put it in your computers here. Okay, so if you want to edit pictures, you take the pictures from the file server, download it to your computers, and you can manipulate that picture with Photoshop, for example, and after you finish, you store the new edited picture to the file server. Okay, that's the file. File server doesn't really need high power computing processing. Okay, because file server usually just for storing and giving the files. If some user asking for a file, the file server will take that file and give it to the users. Now, you can have file servers, and there are plenty of file servers sold in the market. They usually call themselves as NAS product, network attached storage. You can build it by yourself. If you look at the product that's sold in the market, the network attached storage, they usually have a processor, a low power processor like Intel dual core, things like that. Okay. It's very rare to have file server that having Core i7 or any other high-end processors. Why? Because they have no processing requirement. However, network attached storage usually have, or file server usually have high capacity storage. Okay. When I was at photographer.net, we built our own file server. The capacity at that time was 10 terabytes. Okay, so the limitation of file server. First, it's excessive data movement because you store raw files and you download it in entirely. It will be very, very big data to be transmitted. Okay, and you need powerful client workstation. Okay, if you want to manipulate pictures, you need to install Photoshop, for example, which is requiring good computers. Okay. Now, another architecture that's currently is the most popular is called the client-server architecture. It has two components, which is the server and the client. Okay. So this is the difference between file server and client server. With client server, your computer, your device will be the client, and the server will provide with computing services. Instagram, Facebook, Twitter, and any others social media use client server. Instagram, for example. Whenever you upload a picture to Instagram and you apply certain filter, the change of or manipulation of that picture was not happening in your device, in your mobile phone. It was happening on the server side, on Instagram server. Okay, so they applied the filter, they manipulate the picture, they change your pictures based on the filter that you selected. Okay, so the client is just for input and output device. Processing are happening on the server side. Okay, so on client server, application processing is divided between client and server. Client manage the user interface, and then there is database servers. Okay, let me show you the. So this is the architecture of. It's called the three-tier architecture, usually employed by client server. So you will have client computer, you have application server, and you have database server. Our class registration system, the old one, not the online one, the one that you have to come to campuses to register for your class using this architecture. Okay, so you'll sit in the computers, in the computer labs, and you enter your class registration detail. It will be processed by the application server and then stored on database server. That's the three-tier architecture. Okay. So what's the advantage? Okay, we don't need high power computer for our client side. Okay, and it's improved response time, right? Because there's the application will be on the server, and server has very high computing power. Okay, typical computer usually only have one processors, one CPU. Servers could have 4, 8. Okay, one computer, our personal computer usually have like 2, 4, 6, or 8 processing cores. With servers, it could have hundreds and hundreds of processing cores. Okay. It's reduced network traffic because you only receive what you asking for, not the entire file. Okay. And it's encouraged acceptance of. However, it's difficult to migrate from file server to client servers. Okay. There are others problem with that, especially when you design the application for file server and then moving to application server, there's a complication. Okay, so this is the three-tier architecture. Okay. Now, with three-tier architecture, you can have client computer that are different from application server and different from database server. The application server that used for our class registration system, they use Microsoft Windows system. You may access that using your iOS device, your iPad, for example. And database servers could be in Linux or something like that. Okay. Oh. And you can use different combination of different technology. Okay. This is the concept of open system. You can use Apple device to access the system. The server could be produced by Microsoft, and then the software could be produced by Oracle. Okay. It's not uncommon in enterprise or big company environment that you can find many brand for the system. Okay, so how brand from Microsoft, Google, for example, Oracle's, Apple's, and every other IT company could work together. They could work together because they subscribe to open system concept. Okay, so they can communicate with each other, although they came from different companies, different brand. So with three-tier architecture, we have three different layers. That's why it's called three-tier architecture. Data presentation, data analysis or processing, and also data management. Okay, so let me change that. Okay. So with there will be a presentation layer. Presentation is the one that appears in front of you as users. And then processing. This is the one that process the data and also data storage. Okay, so there are three different layers. That's why it's called three-tier architectures. Okay. So with Instagram, for example, your devices become only presentation. The manipulation of pictures are in server side, and also the storage of the picture are also in storage side. Okay. This is the different type of three-tier architectures. Okay. Now, what about internet-based system? Internet-based system is also derivative or using the three-tier architecture, but they expanded. Okay, expanded the system, so it should be like this. Okay. With internet architecture, there will be a web server. Web server is the server that you face or you see when you visit a website. If you click, if you visit, say, internet banking like BCA or Bank Mandiri or CIMB Niaga or any other banking, the website and also all the web page that you look at your screen is reside in this web server. Now, web server is a simple server. Okay, many web servers have a very high powerful server, but basically, web server is just a server that's serving you web page. So how web server works? When you, as a client, requested a page, for example, you want the current news from theday.com. So you go to the Take web server, and then the Take web server will looking for the page that you ask. If the web server find it, it will serve you the page. Okay. And then it will appears on your screen. But if the page that you were looking for could not be found by web server, then it will give you error. Usually 404. Okay, the 404 error means the file that you were asking could not be found. Okay, so web server just sit still and waiting for your request. So they are listening, okay, to your request. So when you request a page, web server will act by looking for the page or document that you asked in their storage. And if they found it, they will give it to you. Okay. And then it will stop working and start listening again. And that's web servers. Web server is so simple that you can build a web server, put into a computer as small as Matchbox. Okay, so very little. In fact, in year 2000, in MIT, they built web server into light bulbs. Okay, so when the light bulbs broken, the web server will tell the maintenance to replace it. That's it. Okay, so it's so small. Okay. So if you visit BCA, for example, and you access the internet banking application, where is it? Because web server could not serve any internet banking. They just sit down and listen to your request. If you request a document, they will try to find that document and give it to you. If they could not find the document, they will give you error message. If they can find the documents, they will give it to you. There is no way web server could process internet banking. So where's internet banking? It will be here on application server. Okay. So the internet banking application will be here on the application server. So how it works? On the web page of internet banking application, there is a special instruction. So when web server read that instruction, so for example, you want to make a transfer. When the web server read this specific instruction, it will pass or give the instruction for transfer to application server. Application server then will process the transfer request. All the data that require, for example, checking the balance, it will be taken from database server here. Okay, and after it finishes, application server will create HTML page, say the transfer was successful, and give it to web server. Web server then will give it to you here on the client side. And that's how the internet banking works. Okay. Now, remember last semester when the kuliah site was unable to be accessed. Where is it? The problem was not here, not on the web server, but the problem, there are two problems actually, on the database side and on application. Kuliah site was not designed at that time to handle that many users. Okay, that's why when usually a typical day before our campus was forced to work from home, before you were all of us forced to use online classes, typical user of our kuliah site usually less than 200, and suddenly at the same time there are more than 500 users accessing. So it has problem to cope with those workload. Okay. Can it be done? Yes, it can. In photographer.net, we serve more than 400,000 users at the same time. Okay, and there's no problem with that. It's just a matter of setting it up. Okay, so it's simpler. Now, with internet system, we have to be aware of plenty of protocols that get involved into. For example, first we need to understand domain name service. Okay, domain name service, if you remember your MIS classes, is a service to translate domain name like clickbca.com, bankmandiri.co.id, uaj.co.id to the specific IP address and vice versa. And then there is hypertext transfer protocol. This is the protocol to exchange documents. Okay, this is the foundation of what we call now as World Wide Web. and also the document itself, hypertext markup language, HTML. This is the document that being shown to you through your web browser. Okay, so let me show you this. You're probably familiar with this. Our kuliah site. Okay, let me go to it. It's a bit slow, probably because a lot of people access it at the same time. Let's go to our other site. You're familiar with our university website. So this is the website that appears in front of you on your browser. Okay, but if you look at this is the HTML file. Okay, so behind the good-looking website, this is the HTML. This is all the code that being executed by your web browser to present to you a website. Okay, so this is our website, our university website. Let's see if we can find one popular today. Okay, similar. Let's see the page source. So this is the HTML file of the day. Okay. Good. Now let's return to our lecture. So that's the HTML. It's hypertext markup language. You don't need specific tools to create HTML file. You can use Notepad, for example. Plenty of early days web designer, they use Notepad for typing in the hypertext markup language. But nowadays they use any other tools that more advanced. But yes, you can use Notepad or any other text editor, even Microsoft Word, to create hypertext markup language. And HTML is a markup language. So if you ever see, let me show you this. So a lot of online course saying HTML programming. Okay. HTML is not a programming language. This is HTML, as you can see, is markup language, not programming language. So if you found any course that offer you HTML programming, that's a false. Okay. But that's a topic for another discussion in another time. Okay, let's continue. So if you look at the internet architecture here, okay, the client could be in various form. It could be a desktop computer, a laptop computer, or this is the one that here, thin client. It could be your mobile phone, could be your tablet, could be entertainment system in a car, like the one that in Tesla, for example. It could be a refrigerator, it could be drone, it could be camera, it could be CCTV and everything. Okay, so that's the basic of technology that we call now as Internet of Things. It means devices or stuff that in the old days were not associated with internet, currently can be associated with internet. You can connect your smart TV to the internet. You can connect your smart refrigerator to the internet. Okay. You can connect your watch, shoes, even, okay, and any other things. And that's not old. Sorry, that's not a new thing. It has been around for so many things. Equipment, for examples. Okay. See this. If you see this, this is the heart rate monitor. It could be connected to doctor somewhere. 10 years ago, some academia in Satyawacana University in Salatiga, they designed a device that monitor a person with diabetes. It monitors the sugar level, it monitors the health of that person, and for some reason, if that person become unconscious, the device will immediately call for ambulance and immediately notify the doctors. So the doctor will be ready to give a treatment. Okay. And also it could monitor the blood sugar level of the patient, and if the blood sugar level fall below certain threshold, it will notify the patient to eat something. If it's too high, it will notify the patient to take insulin or to take medication, things like that. Okay. Now, if you look at a website and if you see the what it calls the appearance, you can see that if you open the website using Chrome, it will be similar to the Firefox, Microsoft Edge, Opera. You know, if you open a website using different browser, you'll find a consistent look, and that's consistency can be achieved by using what is called as cascading style sheets. Okay. In the old days, when you design the application, okay. So when I was learning about programming back in the early 90s, whenever I design the look of my application, I use this let me see now. Now this one. Oh, can't find it. I think it's on. Let me see if I can find. It's supposed to be on the last lecture. Okay. Oh yeah, this. Okay, yeah, this one. Okay, so remember this from lecture 10. Okay, so when I was learning programming and how to design the appearance of my website, my application, we use this grid. And at that time, the application was text-based. Okay, the computer was text-based. It's not graphical like what we have today. So I have to calculate, for example, if I'm not mistaken, the horizontal line would be 40 and the vertical line would be 80. So the position of this should be on a coordinate base. That's why we were having this kind of paper to design our application appearance. and then it's only for a certain size of screen size. It was 14-inch screen size, and the screen at that time, the screen type was text-based screen type. If we move to larger screen, 17-inch for example, then we have to change the design. If it appears on graphic like this one, it's different. Okay, so how a website, if you look at a website, for example, like thetik.com earlier, when you open this website in a 15-inch screen, 14-inch screen, 30-inch screen, it will appear similar. Why? Because they use what is called as CSS. With CSS, all the element of the screen will be placed based on percentage. For example, instead of certain coordinate like 3 to the left, 5 to the down, 3 left, 5 down, they use percentage. For example, this banner will be 30% from the left. So no matter the size of your screen, it will be 30% from the left. And that's how it works with CSS. The problem with CSS, usually different browsers have different CSS. So if I design web-based application, the first thing that the application need to know is to detect the browser. Oh, it's Chrome. Then if it's Chrome, it will call the appropriate CSS. So usually we have CSS for Chrome, Edge, Firefox, Safari, Opera, etc. Okay. Most of the time, Chrome, Firefox, Opera, and those three have similar CSS. So we just design one, that's it. The problem that I found in the old days was with Internet Explorer version 6. Okay, when I use the standard CSS, everything worked fine. It appears consistently on Chrome, Firefox, Safari, Opera. But when we use Internet Explorer version 6, everything just went out the windows, and we have to create specific CSS for that. Okay. But now with Edge, that's a different story. Okay, because Edge, the new browser from Microsoft, was based on Google Chrome. So what's the design consideration in regards to web application? First, obviously, consistency. Okay. You need to be consistent from one page to another. Okay. If you use a red color scheme, it has to go through all the. Let me show you this. This is our university. Okay. This reddish color. But what if we go to the postgraduate school? Different. It has blue and black, while our university have red and whatever it is. Okay. Let's see our faculty. See, it's different. Okay. Different. Okay, now let me show you Google. Google. This is Gmail. And photo. it's consistent. Okay, it's similar coloring, similar theme, similar everything. Why? Because Google use the same design language. Okay, and that's the problem. Okay, and also the one that we need to be very careful with web-based is navigation. Let me show you these examples. The tick. So we want the tech news. Okay. So this is the tech news. Go to save. Just click any news. Okay. So if you look at this, the tech news berita. This is navigation. Okay. So if you lost somewhere, you can always return to the tech news. Or if you really lost, you can go to this the home page, get the initial page, the tech. Okay, so that's for navigation. Design quality, correctness, consistency, things like that. Okay, so that's for the design. Usually, we will have design by specialists that specialize in web design. Okay, so just give it to the people who actually really good in designing a website. Okay. I don't really have a lot of experience in designing a website or web application. Okay, my whole career was built to build the back office of the web application. So if you look at the web application development, there are two different sides. First, they usually call it a back-end development. Back-end means the processing. Okay, my experience mostly on the back-end, and then the other is part called front-end. Front-end is the one that design the appearance, the look and feel of application. Okay, and if you can do both, they usually call it a full stack developer. Okay, not only front end, not only back end, also full stack. Okay. That's it for our lecture today. Any question? Anything you want to ask or discuss?
No, sir.
Okay. Okay, so if there is no question, I think that's it for today. Don't forget your assignment will due next week. Okay, and we will have another video meeting on the last lecture, I guess. Okay, so see you next week and take care.